Lesson 1. Okay, so trigonometry, rotation angles and reference angles. So after today, you want to know what a rotation angle is and a reference angle in the sense of how they're different and how they're compared. Simply, a rotation angle is formed by rotating an initial arm through an angle about a fixed point. So what that means is you have an initial arm that's like stationary, and you move the other arm a certain amount of degrees, theta degrees. If you're not familiar with theta, that's this symbol here. This is kind of like an x, it's a variable it's used often in trigonometry. So it's just a variable if you're confused. Okay, theta degrees. Okay, so you have initial arm, you move the terminal arm a certain amount of degrees. The angle between those two arms is your rotation angle. The angle formed between them is what we call the rotation angle. So you have a positive. If you go counterclockwise, that's a positive angle. So normally when we're doing rotation angles, the positive direction is this way. However, in trigonometry, you can go the other direction, which is negative. If you go clockwise, okay, is negative angle. You can have negative angles. I'll give you a simple one here. So we're going to be dealing with stuff kind of in a quadrant sense. So this rotation is what? 90 and positive. Good. And then this rotation is negative 90. Yes. Okay. That's the difference they're talking about. Okay. Any questions? Okay. Let's get these foundational things done. Okay. So the diagram below shows the angle of 220 standard position. Okay. 220 in standard position. So how this is figured out, just so you know, 90, 180, another 40. That's 220. Example of 220. Go ahead and try example 1 on your own before I do them. Sketch these rotation angles. And it says state the quadrant they terminate in. I'll give you a quick refresh on quadrants. They go like this. 1, 2, 3, 4. So where's your angles at? That's what they're saying. Which quadrant? So you're going to sketch where you think it's going to be. Approximately your sketch exactly the quadrant. Quadrant can't be approximate. Okay. Okay, if you want to check your work. Okay, any questions on any of those? You can. Yeah, I mean, you could draw it like this. It's fine. Yeah. Kind of hard to do there for my pen's on the thick setting. Okay. All right, good. Okay, here we go. Keep on rolling here. Okay, ask questions, guys. Draw a rotation angle in standard position. So right there is a rotation of 150. Okay. It's in 150, so it's already kind of there. And so that would be this way. It says rotation of negative 2/10. So just telling you which way to draw your arrows. That would be this way. And then rotation of 510, 360, another 150. So the point is that all three of those are actually in the same spot. You guys see that? So 150 and negative 210. Same thing. Well, here's the interesting thing. What's 150 plus 210? 360. It's not a coincidence. Okay? So if I go 150 one direction, I go the opposite number of 360 the other direction. So 150 and the 210. 510 is, if you take 510 and you minus 360 from it, you get the 150 again. Okay? So they're all landing on that position. All of those examples, so 150, negative 210, and 510 are all called coterminal angles. They are different values, but they land the same position. These three, yes. Yeah. But you could do that for a lot of them. So like if I was doing 90, for example, Parker, the coterminal to positive 90 would be negative 270. Okay? So it says since 150 is the measure of the smallest positive rotation angle and coterminal with these angles, this is the principal though. So 150 is the principal. So principal is your smallest positive angle possible. So So these are 3 different ways of writing it, but the principle is 150. So what, like the regular angle spot's 150. Okay. So you see the principal angle will always be between 0 and 360. There are infinite amount of coterminal angles. Why is that? Exactly. I can just keep going in circles. Keep adding 360. Keep adding 360 forever. Keep minusing 360. Keep minusing 360 forever. So there's an infinite amount of possibilities for coterminal angles. Okay? Questions? We're good? All right. So for the purpose of the unit, we're pretty much going to stay in the 1 circle range, though. We won't go too much outside 360 for this unit, so that's just more so you know. Okay? Okay. The point P lies on the terminal arm of angle theta. Draw angle theta in standard position. So what they're saying is, make your grid, plot this point roughly where it would be, 1, 2, 1, 2, 3, 4, and then you're going to make a line to the center. That's your radius. And then you're going to draw what that's rotating in positive angle. So I plotted the point, I connected the point to the origin, drew the angle around from the original spot. We always start here too, by the way. This is always our kind of starting spot. So that would be this, the green line I drew represents angle theta, the missing angle. We should know that this angle is between what and what? 270 and 360. Good, Gavin. 270's here, 360's here. So we know it's between there. We don't know what it is. We'll find ways to find this later. That's a good number sense to kind of know what to expect. Okay, -5, -1. So here. There. Okay, and in this case, this one is going to be between 180 and 270. Okay? Okay, so now we're talking about reference angles. Okay, and that's it. So we just did rotation angles. Is there any question on rotation or coterminal angles? That's the only thing we talked about so far. Straightforward, everything easy so far? All right. So here's reference angles. Reference angles are this. Reference angles are the distance, the angle measure, let's say angle measure, not distance. Will be distance later for radians, but degree measure back to the x-axis every time. That's a reference angle. The degree measure back to the x-axis every time. So see this right here? This is the rotation angle. However, the reference angle is this angle, back to the x-axis. So if I have one here, that's the rotation, but the reference angle is this one. Yeah, however it's sliced, and that's every time. So I'll keep explaining, okay? Let's go every quadrant. So this one would be that angle. This one, that angle, this one, that angle. Always back to the x-axis every time. Okay? Now the cool thing is that there is positions. So as we do this, the reference angles represent the same position, but different sign. And I'll explain that in a little bit, okay? It's really going to come through with your project. But let's go and look at this here. It says the diagram shows 141 with a reference angle of 39. Okay? So let's actually mark this how they had it. So what they're saying is this right here is 141. This is 39. Which makes sense, right? Because what's 141 plus 39? 180, which we see that's what it is, right? Okay. Now, I'm going to bounce around here, and it's okay if you answer wrong. Okay, I'm going to call on people to kind of give you some answers here. So why don't you participate? Okay, 243. What quadrant is 243 in, Woodsky? Just before 7, so it's right here, right? Okay, good. All right, so then, Lucas, what is this angle? 63, good. How did you get that? 243, he minus the 180. You guys see that? So 243 is this whole distance, right? He subtracted the 180 off to get what's left over. for that quadrant. Each quadrant's going to be different. So like what he's saying is, and maybe you're not, Parker, but you're not minusing 180 every time to get this. It's not that simple. You have to know which quadrant you're in. Okay? So 243 minus 180, 63 is correct for the reference angle. So then 337, Riley, where's 337 at? Which quadrant? 4. Good. So it's right here. Okay, Parker, do you want to? How would I get this one for a reference angle? Other way around. 360. Yeah. Yep. So you see that? So we want 360, the whole thing around, minus the 337. That'll give me the leftover piece, right? So you're taking 337, subtracting from 360 to get that leftover piece. So you get 23. 23 degrees is that reference angle. Every time you do a reference angle, here, this is something if your person wants to hear all the time or every time, every reference angle will be 90 or less. If you get a reference angle bigger than that, you messed up. Right? Because we're always going back to the x-axis. So no matter where I'm at, the farthest I can be is here, right? 90. You'll never get more than 90. Okay? Let's see some thinking going on. Any questions? Okay, let's do one more. Joel, which quadrant is 70 in? 1. Easy one, right? Because 70, if 70 is here, well, what's the distance to here? Boom. Quadrant 1's the easiest one. So 70 is your reference angle. Okay. We're going to put together a chart, I believe. Yes, we're putting together a chart on the last example here of which quadrant you do what, if you want a more directed approach. If it say when it came. Yeah. Yeah, you put the same thing. Yeah, 70, 70. Well, no, you would label it reference angle 70, rotation 70. It'd be this, like, we're not changing the location, right? So you're labeling what the reference angle is. In quadrant 1, the reference angle equals the rotation angle. Okay, example 5. On the grid, draw a reference angle of 58 in each of the 4 quadrants. This is the interesting part, okay? So we're going to draw 58 in all 4 quadrants. So I'm roughly going to do that. 58, we'll say, is right about there, right about there, right about there, and right about there. So we'll say these are all 58s for reference angles. And so I want to tell you guys this. This will be a little bit off topic here, but it's going to help you with the idea of the unit circle. Why these are important is that I want you to think about something. And I have these drawn not quite to scale, but pretty close. Let me get this to be the same height here. And let me get this one to be the same height down here, a little bit farther. Okay, so check this out. If they're making 58, this makes essentially like a rectangle. And since it makes a rectangle, what do you notice about these 4 lengths? They're equal. That's really important. And what do you know about these 4 lengths? Well, they're also equal. And so that's why the reference angle is important, is because the only thing that's going to change is the sign. I'm going to be very, very generic here, and I'm getting off topic. This is not for today. This is for understanding. Okay? Do you guys understand that that's like an x coordinate and that's a y coordinate, right? So let's just call this, for being easy, let's call this 2, 3. It's 2, 3 in quadrant 1, right? What's it in quadrant 2? Negative 2, 3. That's a big concept for the unit circle. That's a big concept for trigonometry people to understand. Those reference angles represent the same position, which is the same values, but different sign. Right? And I made those values up. 2 and 3, I made those up. I didn't get those from anywhere. Okay, we'll have them. Okay, but that's just the idea. All right, off topic, but that's okay. All right, we drew that. State the measure of the rotation in each quadrant. So now they want to know, each quadrant, if you have reference of 58, what's the rotation? Well, quadrant 1's easy. 58, right? 58's rotation angle with the reference angle 58 is 58. All right, quadrant 2, what do you do? Good. So you're at 122. Okay, quadrant 3. 180. Yep, not 270 because that's y-axis. We always say x-axis. So you'll always, I'm glad you said that, because you're always going to use a 180 or 360 on these, okay? Because 180 is here and 360 is here. It'd be 180 plus 58. Because it's 58 more than 180. See what I'm saying? Questions? It's asking for every rotation angle with reference of 58. Oh, you mean if it's a rotation angle. If it was 238 and I want the reference, I'd minus 180. Yep. Okay. Quadrant 4. So we would go 360 minus 58. So 302. So all of these rotation angles have the same reference angle. So all of those rotation angles are in the same position but different quadrant. That's what I'm trying to sell to you. Questions on that? Okay. So it says let point 58 be a point on the terminal arm of the rotation angle in quadrant 1. State the coordinates of the points QRS. We just did this actually, but with 2, 3. So that means it'd be 58, right? So change my 2 3s to 58. So what's in the second quadrant? Negative 58. So this is quadrant 1, quadrant 2, both negative, good. Positive 5, negative 8 for quadrant 4. Okay? Good work. All right, we got quickness. Okay, here we go. Last page. Yeah, only way to do it, right? Okay. Here we go. This is a great little building table of this. Determine the measure of the rotation between 0 and 360 given the reference angle in the quadrants. They're saying, here's your reference angle. It's in this quadrant. Tell me the rotation. Okay, so I'll do the first one. I'm going to pause it. I want you guys to try the last 4 there. So 25 in quadrant 2. So that means this is 25. So I'm trying to figure this out. 180 minus 25, 155. It's my rotation angle. Go ahead and try a couple. I'll pause the video. Okay, so I'll put them up here, guys. You guys tell me if you got them right or wrong, if you're not sure why. Okay, so drawing them. So this is 30, 60. So you go 360 minus 60. This one's 300. Okay, you'd go 360 minus 60. 8 in the third quadrant, that's here. You'd go 180 plus 8, 188. 39 in the first quadrant, nothing to do. 39. Quadrant 1's quadrant 1. 90 between 3 and 4 because it's right here. So that means it has to be the 270. You can only have 90 at what 2 spots? 90 and 270. The top and the bottom, right? 90 and 270, the only ones that can get you 90. No, because I guess it's nothing. Yeah, this wouldn't be, I don't think it'd be anything. Okay, determine 3 angles between 0 and 360 which would have the same reference angle as 256. So what you want to do is what is 256's reference angle, and then use that to find the other 3. Okay, so 256 we should know is right there. So it's 180, 256 minus 180. So you get 76. So reference angle is 76. So that's the quadrant 3 one. So quadrant 3 is 256. Quadrant 1 then is 76. Quadrant 2 and quadrant 4 are the only 2 you have to do work with. A little bit. So quadrant 2, 180 minus 76. 104. Quadrant 4, 360 minus 76. That'd be 284. And you're done. All 4 of these spots are this, have the exact same reference angle for rotation angles. Okay, any questions? All right, finish up.